everybody. So today I'm going to show you the last special types of linear systems lesson for this particular unit from chapter 7. With this lesson we will conclude chapter 7. We're going to do some review practice and then summative assessment. So special types of linear systems. On the left it says that you will work on 7.5 worksheet. We will spend one day on one part of the worksheet and another day on 7.5b. So let's begin with, we have given graph and 1, 2, 3 lines on the graph. Can you determine which two lines are parallel? So if you look at the graph, which two do you think will be parallel? Well, I think you already see that line 1 and line 2, so I'm gonna say 1 is parallel, oops, not perpendicular, parallel. 1 is parallel to line 2, and those will be the only two lines. The reason line 3 is not parallel, because if it goes that way, will cross line 2 at some point over here, and if you continue going, keep going, will cross line 1 as well. And we know parallel lines, they never cross each other, and also all the points from both lines are an equal distance. So why I'm saying that? The reason I'm showing you this is because linear system, when we have two equations, it means those two equations represent two lines. Sometimes we will have a case when the two equations will show no solution or parallel lines. They never intersect. Sometimes those special types of systems may have infinitely many solutions, and we talk about that infinitely many solutions will be if line 1 goes this way and line 2 it goes on top of 1. So if two lines are on top of each other, we see it as a one line on the graph. It means infinitely many solutions because their points intersect all the way through the line. So let's take a look what the equations look like for this type of special systems. Now, if I have a system 3x plus 2y equals 10, and we learn to use elimination method, and we gotta choose which term, x or y, have the same coefficient number up front, and if it has the same coefficient number, then we need to check if they have positive and negative sign. So in this case, we have 3x and 3x, 2y and 2y. Both of those variables have exactly the same number in front of the variable. So I would say just pick one of those two. Let's say we want to pick 3x and we want to cancel those. Next step will be to use subtraction method because both of those have the same number, plus 3 plus 3. So we're going to use subtraction method in order to cancel those. And subtraction method will give us 3x minus 3x 0, 2y minus 2y is plus 0 again, those two cancel, and then we have 10 minus 2 is 8. 0 plus 0 is 8 equal 0 plus 0 is 0 equal 8. Well, is that possible? This is not possible. So since it's not possible, we are saying that the system has no solution. This is a perfect example when you're working with elimination method and you're canceling some stuff and you gotta check left side of the equation and right side of the equation, and if they are not the same with the same numbers or variables, we say not true statement, no solution. Alright, so another example will be show that the linear system has infinitely many solutions. Well, let's see. So draw a line. We have 2x, negative 2x, y and y equals 4 and 4. Again, pick one of those that you want to cancel. Let's say this time we want to cancel y and y. They are the same. Number 1 stays up front of both, so we are choosing those two. And because one is negative and the other one is positive, we're going to use addition method. So addition method will be 2 plus negative 2x, which is 2 minus 2x, 0, Negative 1 plus 1, those two cancel, plus 0 equals to 4 minus 4 is another 0. So here's what we have, 0 equals 0. Everything gets gone. If it's 0 equals 0, and we have exactly the same left side equals to the right side, then we can tell that we have infinitely many solutions. So this is a true statement, and we have infinitely many solutions. Number on the left is equal to number on the right side. Alright, next one, the last one, is show that the linear system has only one solution. Well, when the system has one solution, it is the only way when we calculate, we solve the equations, we simplify, we solve the equations for x, then we solve for y, and we have order pair with x and y coordinates. And let's show that. So, we have y minus 2x equals 3 and x plus y equals 2. Well, do you see something here that is a little bit strange and doesn't fit very well? I hope you see that. So, first one is y minus 2x, the second one is x plus y. So my variables do not align correctly. This is y, this is x. This should be y and this should be x if we want to use elimination method. So we just need to rewrite the system. We will write the same one, the first one, y minus 2x equals 3. And this I will just flip those. We'll switch the variables. So positive y on the top and positive x next equals number 2. So now my system has all the columns with the right variables and numbers set up. So from here, we can choose those two variables. They have the same coefficient number 1 and 1 up front, so we can choose to cancel those two. And because both have the same positive sign, we need to subtract the equations. So 1y minus yy, 1y is 0, cancel. Negative 2x minus 1x will give us negative 3x equals 3 minus 2 is 1. So 0 minus 3x is just negative 3x equals 1. We'll divide by negative 3 and we will get x equals negative 1/3. So that will be the solution for x coordinate, negative 1/3. What do we used to do as a practice when we learn those one solution systems? Well, we used to substitute x or y value back to the original, one of the two original equations. So let's pick the first one, y minus 2x equals 3. And we're going to substitute x with negative 1/3. So I'm continue to writing this, y minus 2 times, instead of x, negative 1/3 is equal to 3. So we will multiply those two numbers. Will be y, negative 2 times negative 1/3. We will get positive 2 over 3. Negative times negative is positive. 2 over 3 equals 3. Okay, one more step. We'll subtract 2/3 minus 2/3 from both sides. So y will be equal to, and now I will suggest use the calculator. You don't want to think fractions right now. So will be 3 minus 2 divided by 3, and we will get 2.33 approximately. And that will be the answer. So I will put 2.333. You can definitely convert that to a fraction, which will be 2 and 1/3. So this is our 2 and 1/3, or also as an improper fraction will be 7/3. And that will be the final answer. So please remember, the whole idea of this video is, if you have systems, when you get your x and y coordinates, this is one solution. Everything else could be no solutions type or infinitely many solutions type. So once you complete and you figure out by substituting and canceling what goes away and what stays, then you can decide which one of those special type systems we have presented. Thank you for watching the video and have a great day.